Alright, disjoint or independent. So in exercise 24, you calculate a probability involving various blood types. Some of your answers depend on the assumption that the outcomes described are disjoint, and that is they could not both happen at the same time. Other answers depend on the assumption that the events were independent. That is, the occurrence of one of them doesn't affect the probability of the other. Do you understand the difference between disjoint and independent? So if we examine one person, that's the key, one person, are the events that the person is type A and that the person is type B disjoint or independent? Well, we're talking about one person, okay? So we're trying to figure out which category they fit in. Now, a person can't be type A and type B. Okay, they're either type A or type B. Okay, type AB is not type A and type B. It's a different blood type. So when we're trying to figure out which one of these categories the person fits into, that is a disjoint event. Okay. Now, problem B, if you examine two people, are the events that the first is type A and the second type B disjoint or independent? Well, we're looking at two people, we're trying to see if one influences the other. Okay, so if one person has type A blood, does that affect the fact that the person has type B blood, the second person? Well, no, it doesn't, because they're independent. Okay, so knowing what blood type the first person has does not affect what blood type the second person has. Can disjoint events ever be independent? Well, no, they cannot. Okay. If we know, if you go to the doctor and you say, okay, doctor, I want to test. I want to know what kind of blood type I am. Okay. Well, before you walk into the doctor, these are the probabilities of the different blood types. So you have a 45% probability of being type O, 40% of being type A, 11% of being type B, and 4% of being type AB. Okay? Now remember the definition of independence. The definition of independence is when one event occurs, it does not change the probability of the second event. Okay? So you go to the doctor and you say, okay, doctor, what blood type am I? He says, okay. He says, I'm going to run the test. Now, before the test, the probability that you were going to be type O is 45%. Okay? So the doctor comes back with the test result and he says, guess what? You are type A. Okay? Well, now that you are type A, what is the probability that you are type O? Well, it's not 45% anymore. It is 0. Okay? You cannot be type A and type O. So the probability changed. And that is why disjoint events cannot be independent, because if it was independent, the probabilities would not change when one event occurs. So disjoint events cannot be independent, because once you know which category you fit into, all the other categories go to 0, and they lack independence.